Welcome students, this is your video for Wednesday 8/27 on Scatterplots. A scatterplot is a graph of points or dots used to show a relationship between two items or groups or quantities or something or things. Okay. This first picture, this is our scatter plot. Here is our x-axis and our y-axis, and here are our dots. These dots go in an upward motion, so these are said to be positive correlation. Correlation is basically made up of two words. Co means together, and relation means how things fit together. So these fit together in a positive situation. The definition of positive correlation is when both sets of data increase together. So the dots are going this way, which is increase, and the dots are going that way, which is increase. And so they're getting higher and further away from this zero down here. These dots, as we look at them, they clearly go downhill, and so that's said to be a negative correlation. If you look at it, that arrow would point down. In a negative correlation, the points are still going to the right, which is a positive, that's increasing. But on the y-axis, these dots are coming down or decreasing. And so in general, one set of data decreases while the other set increases to create a negative correlation. When the dots don't fall in a clearly defined pattern, when they're just randomly placed all over it, we say that these sets of data have no correlation, or they're unrelated to each other, and that's the definition we use. They're just not related, they're scattered dots. In the first two pictures up here, we were able to draw a line. This is called a trend line. And a trend line on a scatter plot shows the correlation more clearly. This line clearly shows that those dots go uphill. This line clearly shows that those dots go downhill. When we draw a trend line, we're not trying to hit all the dots. All we're trying to do is go through as many of the dots as we can. We want to split them up, some on the bottom, some on the top of it, and we want to hit some along the way. Here are two more important vocabulary, and all of these are important vocabularies. You're going to put these in your vocabulary section when we get back to class on Wednesday. All of these things with the asterisk beside them are going to go in there. The independent variable, and then we have the dependent variable. We have a saying that we use up here in high school that helps you guys kind of remember that. It says, "Why am I so dependent on my X?" Okay? So it says, why am I so dependent on my X? And so in this situation, it's asking, why am I so dependent on my ex-boyfriend or ex-girlfriend or that type of situation? And it's supposed to be just kind of a catchy phrase that helps you remember that the y is always dependent. So the dependent variable belongs on the y-axis, or that's the vertical axis. And if y is always dependent, then that means that our x-axis is our independent, and that is the horizontal or flat axis. Alright, now we're going to get into working some of these problems. To make a scatter plot, you plot these points just like you did back in middle school and elementary. This is your x, this is your y. X's always go left or right, and y's always go up or down. In our case, we're dealing with this real world situation. All of these are positive, so we're only going to be going left and then up. So if we're plotting hours worked versus amount earned, and you may understand the relationship between this already. If you have a job, or if you have brothers or sisters or parents that have a job, you know that the more they work, typically the more they earn. Let's see if this data ends up showing this. Janelle works 6 hours and makes $25.50. So these are going by 2, so 2, 4, 6, and we're going to go up $25.50. And these little lines go up by 10, so 10, 20, 30, so $25.50, and don't worry about being able to exactly find it. It's going to be right in this area somewhere, not quite 30, but somewhere between 20 and 30. Roscoe, for 12 hours, gets $51. He goes over 12. 50 is going to be right above that line there. 11 and 46.75, so for 11 hours, that's 10, so 11 is here in the middle, up to 46.75, so that's going to be somewhere in there. Alex works 9 hours at 38.25, so 9 is going to be between 8 and this line, and up to 38.25, so just below the 40. Jordan, 15 hours, 63.75, so that's 12.14 would be there. 15 is going to be just past it and up to 63, so somewhere in that area. You can see these are forming a pretty good line here. Over 10 for Jennifer and up 42.50, so 10 is here, 42.50 is going to be right in there somewhere. Alright, it says to draw a trend line. If I worked 0 hours, I would more than likely get 0 money, so it's going to come through here and pretty much hit those like that. Independent variable we said was the X, and the X is hours worked. Dependent variable is the Y, and that is going to be our earnings. It asks us what is the relationship between the number of hours worked and the amount of money earned, and that's that relationship I was telling you about just a minute ago. As hours go up, money goes up. The more I work, the more money I make. Type of correlation, pretty easy to see that these dots are going up in a positive manner. What is the data point? 1146.75. If you go find that in the data, it's right here. Victoria works 11 hours worked equals $46.75. Predict how much Conrad would earn if he worked 2 hours. So 2 hours, hours is on the bottom. So I'm going to go over 2, up, and across, and that tells me it's between 0 and 10. It looks like, between 0 and 20. It looks like it's about $10 for 2 hours worked. Alright, the next one here, we do have a correction to make for this to turn out nicely. We're going to change this 55 to a 66, and this 55 to a 66 also. Okay. We have some years over here. It looks like we have 3 things, but really for our table, or for our graph, we're just going to have 2, an X and a Y. This is going to be newspapers. And this is going to be TVs. Both of these are in the millions, so it's important to understand that along the way. And we have some kind of tricky numbers to go by. Looking at our numbers here, they go from 54 to 66. Well, those are real clumped up, and there's no way to fit those on here. This little thing right here indicates a break in numbers, so that allows me to start at a smaller number. So I'm going to start right here. This is going to be 50. And then I'm going to skip over to 54, skip over to 56, skip over to 58, skip over to 62. Let me make sure I did that right. Oh, nope, I'm going to go backwards on that. I don't like the way those worked out. So 50, that's 52, that's 54, and then that'll be 58, and that'll be 62, and that'll be 66. I'll go by 4s but skip 1, so they kind of really go by 2s. Up the right hand side I have 10 marks, and I got to basically get to 100, so I can go to 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Alright, so I'm going to get to plotting here. At 54, we go up 4 million. So 54, not going to go up very much, right in there. Then at 59, that's going to be 60 in the middle. So 59 will be right here in between the two. I'm going to go up to 46. So kind of right in the middle there. At 62, I got to put 3 points. I'm going to go up to 59, which is right there. Then I'm going to go up to 76, which is right there. And then I'm going to go all the way up to 92 there. And then at 66, I'm just a tad bit off the chart. draw my trend line. So again, you can see here our trend line. I'll draw it in red so maybe you can see a little bit better. Notice how I'm not trying to hit all the dots. I'm just trying to get the general pattern of the numbers. My independent variable is always my x. My dependent is always my y. And so what is the relationship between newspaper circulation and the number of TVs? So as newspaper increases, TVs increased. If both increased, then again we have a positive correlation. 66101 represents at 66, when there were 66 million newspaper subscribers, we had 101 TV watchers or households with TVs. Predict how many there would be for 30 million TVs. So TV is on this side. I go up to 30, across and down. And so that's 54, 56, about 57 million newspapers during that time. Alright, stay with me here. These last ones are really important for our district tests and campus tests that we take here coming up in a few weeks. We're having to do it from a word situation, so you got to read and figure out, are these both going up? Is one going up, one going down, or are they completely unrelated? So the number of days spent on vacation and the total cost. So as my vacation goes up, number of days goes up, what's going to happen to my cost? It is also going to go up. Up means positive. The length of a rope and the number of knots tied. Think of it this way. If I take a rope and start tying knots in it, so if I make the number of knots go up, what's going to happen to the length of the rope? The length of the rope will start to go down because I'm using up all of my rope by tying the knots. So if one goes up and the other goes down, this is a negative correlation. The height of grass and the height of trees. Trees always they just continuously grow. Okay? Very rarely do we cut trees down, but it can happen. But most of the time, trees grow up. But on a regular basis, we change the height of our grass through mowing. So sometimes grass goes up, sometimes grass comes back down. These two items are unrelated to each other because when I mow the grass, it doesn't really affect the trees. And if a tree is chopped down, it might not necessarily affect the height. So this is said to have no correlation. Those are unrelated. When we have points over here, from 4 to 10 to 14 to 18, that's going up. From 14 to 35 to 49 to 63, that's also going up. 2 ups or 2 increases. It makes for positive correlation. Okay? Before you come to class the next day, I want you to create your own positive. So 2 situations that are both going to be increasing. Your own negative, where one goes up and the other comes down, and 2 unrelated. Usually the 2 unrelated are easier because you can think of just silly things and it'll work out.